Hey everybody, I'm working on a new front axle design and I have the choice of either narrow kingpin or wide kingpin spacing. I'm happy with my track width, that's the width from the outside edges of the tires. I like 11.5, that's with two wheels. So I could keep the same track width by either using a narrow axle with wide hub spacers or a wide axle with narrow hub spacers. The big difference will be something called scrub radius. So I need to investigate how significant this scrub difference really is. Also, I want to explore something that is uncommon, but I hope to make a case for why I think a high scrub radius could be good for an RC crawler. On this channel, we look at the science behind our grown-up toys. There are a lot of builders and drivers that I respect immensely who prefer low scrub radius and correct Ackerman steering. But for me, I think there's an opportunity to focus on other aspects of steering geometry that will help a crawler climb tricky sections, if you're willing to compromise traditional scrub theory. If you look at deluxe portal axle options, you can get a class 3 axle, which is XR width, that is 9 3/16 wide, or a class 2 axle, which is AR44, that is 8 5/8 inch wide. That's about 7 millimeters wider, or just over a quarter inch wider on each side. If I keep the track width the same, is that 7 millimeters wider enough to make a difference? This is a top view of your axle. Imagine this tangerine dot is the kingpin. The kingpin is the pivot between the axle and the steering knuckle. It's the axis about which your tire pivots or steers when it's turned. This is the front view. Notice the ground. This is the axle. This is the steering knuckle that your tire is connected to. And this is the kingpin. For now, I'm just showing the kingpin vertical and centered in the wheel. Most cars aren't actually like this in real life, and I will explain why, but let's start here to keep it simple. Back to the top view, or actually imagine this is the bottom view, and you're looking at the contact patch from the bottom up, as if the tire is on a piece of glass. These red triangles show areas of your tire, the areas of the contact patch that are scraping or sliding or scrubbing across the ground. The tire pivots around the center point of the kingpin, but away from that center point, the tire is actually sliding or scrubbing. The further away from the pivot, the more sliding and slipping that has to take place. This would be a zero scrub configuration, or a zero scrub radius, even though parts of the tire are slipping and scrubbing. The pivot point is dead center in the contact patch. This is why you see these turning skid marks in your fresh concrete driveway if you turn the front wheel and you're not rolling. Most vehicles don't have the kingpin directly in the center of the tire. Part of that is by design, and part of that is actually by necessity. It's an engineering challenge to try to package your steering knuckle plus a disc brake and suspension linkage inside the front wheel. Let's look at this exaggerated example where the kingpin is inboard of the tire. When you steer in this scenario, the entire tire scrapes across the ground. It doesn't just pivot. This is called the scrub radius, which is the radius or the distance that the tire pivots away from the kingpin center. Here's what the sliding or scrubbing zone looks like now. The entire wheel is sliding back and forth, more like a windshield wiper. Low scrub radius is when the wheel simply pivots around its contact patch. A high scrub radius is when the wheel actually sweeps an arc. And this is a little bit exaggerated, but it's the basic idea. You can have positive or negative scrub. A small amount of scrub is usually desirable, and negative scrub is generally preferred over positive scrub for a variety of reasons. Most full-size cars are designed with a small amount of negative scrub. Negative scrub is when the center of the contact patch of the tire is on the inboard side of the kingpin pivot. Most full-size cars are designed with a small amount of negative scrub. You might be thinking that it looks physically difficult to get that steering axis skewed to the outside of the tire, and you'd be correct. We'll look at some methods of achieving negative scrub in just a moment. Negative scrub acts on your tires like this. There is more scrubbing and friction acting on the inside half of the tire, and the kingpin pivot is towards the outside of the tire, away from the chassis. This is negative scrub. This negative scrub, which creates more friction to the inside of the tire, generates a small amount of turning force on the wheel. Imagine the car is driving in this direction. This forces the tires to toe in slightly, which makes the car drive straighter, hold a line better, and provide some physical feedback to the driver through the steering wheel. If you have zero scrub, the car feels vague, dead, and wanders. Also, scrub comes into play when you are braking. Too much scrub radius and your wheels will want to turn under hard braking, which is not generally desirable. Modern full-scale vehicles have maybe half an inch to an inch of scrub, so it doesn't take much to hit the sweet spot. The theory is a little different for all-wheel drive and four-wheel drive because in this case, the wheels would be pulling forward, creating a toe-out scenario. That would make for a good future video since our crawlers are four-wheel drive. This is a skid mark I made with my all-wheel drive sedan. This is the driver's side front wheel. I turned the wheel full lock left and right 3 times, and this is the print it left. You can clearly see the pivot point and the area that is scrubbing more. In this case, it would be a positive scrub radius because the pivot point is towards the inside of the car and the scrubbing is towards the outside of the car. You can try this on your own car. Let's take a look at wheel offset. This is one of the tuning parameters for scrub. Many vehicles will have the Kingpin tucked inside the wheel. This requires that the wheel is offset, meaning the tire is offset relative to the mounting face of the wheel. Positive offset is when the tire is offset inboard toward the chassis. One thing to remember is that engineers very carefully design wheel offset to work with specific axles and Kingpin locations. The scrub and other parameters are very deliberately defined. Note that there is zero scrub in this diagram. The Kingpin is still centered with the tire. This would be zero offset, where the hub mounting face is dead center with the tire tread. And this would be called negative offset, where the tire is moved outboard away from the chassis. You will see this in aftermarket vehicles all the time. No offense if this is your truck, but when people put on this type of deep dish, high negative offset wheels, they have most likely moved well out of the range that the original axle engineer intended. This will make your vehicle handle much differently than originally designed. Many would argue that the handling is much worse, but it kind of depends on what you're going for. Wheels and axles should be designed as a system. I can't say for sure, but normally your steering knuckle isn't so exposed on the inboard side of your wheels. This looks like high negative offset wheels and possibly some hub spacers in there as well. This will create some odd handling characteristics because the scrub radius is no longer where the axle engineer originally designed it. The main purpose of positive offset in the wheel is to try to tuck in the knuckle and disc brake inside of the wheel. This makes it easier to achieve low scrub and negative scrub. Because it's not always possible to hide your steering knuckles fully within the wheel, another way to engineer scrub radius is with Kingpin inclination. You will very often see the Kingpin steering axis is slanted like this. We're looking at the car from the front. Here's the ground. This angle is called Kingpin inclination, or KPI for short. In this diagram, we have zero scrub. That's because the steering axis, or the Kingpin inclination, when it's projected to the ground, perfectly intersects with the center of the tire contact patch at the ground. This is positive scrub when the tire contact patch is outboard of the projected steering axis. And this is negative scrub when the tire contact patch is inboard of the projected steering axis. This is a great way to achieve a negative scrub without having to put the knuckle inside the wheel. Also, when you have Kingpin inclination, when you turn the wheel extends down or lifts up this corner of the vehicle. This is by design. It creates a recentering effect. The wheel wants to fall back down to its neutral position. This is a way to use spring preload and chassis weight to help hold the wheel center and move them back towards center. Is this recentering important on an RC car? I'm going to say not really, because A, you can't feel the steering wheel. Yes, you can intuit what the feel should be, but unless your controller has force feedback like some video game controllers, you can't directly feel the steering recentering like if you were driving a full-size car and holding onto the steering wheel. And number two, your steering servo is going to hold your wheel straight no matter what. Some self-centering effect in an RC car might help to keep the wheel straight if you have sloppy linkage. And let's face it, who doesn't? But personally, I'm not seeing the need for a high Kingpin inclination angle on an RC crawler, assuming you can get the scrub radius that you want. If you look carefully, you can see how the chassis is rocking side to side because of the tire lift from Kingpin inclination, combined with caster. One thing to be aware of is that if you change tire size, your scrub radius will also change. So when you're debating between 1.9 and 2.2, or between 5.25 and 5.8, be aware that this will change your handling. Like I said, many builders whose opinion I respect would adjust the scrub radius for different sized wheels. On a slow-moving RC crawler, it might not be that big of a deal, but that's for you to try and decide. Just be aware of this when changing wheel sizes. Just a quick note on caster, which is not directly related to scrub, but important to understand anyway. This is a side view. Caster is when your Kingpin is tilted backwards. Remember, it's also tilted inwards, and this is the Kingpin inclination. When you're looking at it from the side and it's tilted back, this is called caster. It's totally different and independent from KPI. Caster is a fore-aft angle, inclination is a side-to-side angle. What you should see here is that the contact patch of the tire is behind the projected Kingpin angle. The purpose of this is entirely for recentering and stability. When the car is driving forward, the wheel gets pulled behind the steering axis because the contact patch is putting a force that's pulling backwards behind the steering axis. Without some caster, the steering would feel vague and unstable. If you have a hard time remembering caster, camber, etc., think of it this way. Caster is the same as caster on a shopping cart, or perhaps your rolling tool chest. Whichever way you push the cart, the wheels steer automatically in that direction. Again, this is because the contact patch of the wheel is behind the steering pivot. I actually put 4 casters on my tool chest so I could roll it around in any direction. It might appear counterintuitive, but it's the exact same concept. Caster provides a self-centering effect because the wheel tends to automatically steer in the direction of travel because it's being pulled behind the steering axis. This same concept exists on bicycles and motorcycles, though it's called trail instead of caster. And this is why you can ride a bike with no hands. The caster or trail falls behind the steering axis and keeps the wheel pointed straight ahead, even if you're not holding onto the handlebars. With caster, when you steer your tires, they go up in the front and down in the back. This is why your chassis rocks when you steer left and right. Of course, this is added on to the effects from Kingpin inclination, and you end up with this weird 3-dimensional wheel movement where the wheels move up and down, not just steer left and right. There's actually a lot going on. So, my theory is that super high scrub radius can help you reach higher and pull your vehicle up and over. It artificially extends your wheelbase. Think about that. Also, you can essentially climb by steering left and right. Here are some actual numbers. So back to the original question. How much does it matter to have a narrow axle versus a wide axle? A narrow Kingpin versus a wide Kingpin position? I made this diagram in my CAD software so I could look at the numbers quickly. This is the top view. These are the front wheels. These are the rear wheels. And the front wheels are turned at 50 degrees. This is the high scrub narrow axle. You can see that the axle has the kingpins closer together. This is the low scrub wide axle. You can see that these Kingpins are closer to the tires. So this is the wide axle, this is the narrow axle. Both are turned at 50 degrees. And what I'm going to do is measure from the center of the front contact patch to the center of the rear contact patch and compare those distances. So one is 13.7 inches and one is 13.4 inches. That's about a 1/4 inch or 6 millimeters different. To me, that seems significant enough to pursue. That little bit of extra reach is definitely going to help me grab higher up onto things. It's kind of like having a free, longer wheelbase when the wheels are steered. So I'm going to go with the narrow axle. And maybe down the road, I can figure out how to get even more scrub radius. I do have some thoughts on setting up the scrub radius on a rear steer vehicle, and I'll talk about that in another video. In short, it's pretty much the opposite of what I want to achieve in the front. One thing to keep in mind with a high scrub setup is that your side hilling might be compromised, meaning the vehicle could tip over more easily. But let's look at some numbers and see if it's significant or not. So this is the high scrub axle and this is the low scrub axle. And what I've done is drawn a line from the outside edge of the tire to the inside edge of the tire. And we'll compare the angle of these two lines. This is basically an imaginary line that the vehicle will tip over if you're on a steep side hill, and if this is the downhill side. The high scrub truck has an angle of 86.5, and the low scrub truck has an angle of 86.8. I don't think that 0.3 degrees is really going to be enough to worry about, but we'll have to see on the trail. It seems like the side hilling is probably not going to be compromised very much. My assertion for this experiment is that a slow-moving RC crawler is much less influenced by things like caster and Kingpin inclination. So why not use scrub for reaching and climbing? Call me crazy if you like, I can take it. Personally, I want every advantage I can get when the situations are the toughest, and I'll deal with a suboptimal tune on the easy terrain. I want top performance during the hardest terrain. So let me show you what this extra reach from a high scrub radius can do on the trail. With a high scrub radius, you can alternate pulling with each wheel. And you can stretch your wheelbase by reaching up with one wheel. What I'd like to see, which I don't believe exists yet, to my knowledge, is a narrow portal axle with 0-degree kingpins. Deluxe offers 0-degree kingpins for straight axles, but not for portal C-hubs, so I may have to design my own. Also, I'm going to set my kingpin vertical, no caster, which is possible with the splined C-hubs. My goal will be 0 caster, 0 kingpin inclination. Maximum scrub, which would translate into this improved reach I've been talking about. It may not drive great on smooth, high-traction surfaces, but it could be amazing on steep, complicated obstacles. Do you want to optimize your vehicle's performance for that super tricky crux move, or are you more concerned about stable handling when you're racing between gates or driving in between sections? That's up to you. Hopefully, I can get a prototype built with everything I'm dreaming about. For now, I'm going to go with the narrow axle, wide hub spacers, and maximum scrub.